this video, we're going to discuss the empirical rule. It's also referred to as the 68-95-99.7 rule. Okay, so the empirical rule states that for data sets having distributions that are approximately bell-shaped, okay, so that's a key part to using the empirical rule. You can only use it for data that are distributions that are approximately normally distributed or approximately bell. Okay, so about 68% of all values are within one standard deviation of the mean. 95% are within 2 standard deviations of the mean. 99.7% of all values are within 3 standard deviations of the mean. Okay, so if we were to draw this out, so this is my bell-shaped. This is my bell-shaped distribution, right? So approximately normally distributed, and here is the center. Okay, so I'll have X bar, and then 1 standard deviation from the mean. Okay, so within 1 standard deviation, so 1 standard deviation below the mean and 1 standard deviation above the mean. 68% of the observations are between 1 standard deviation below and 1 standard deviation above. Okay, then 95% are within 2 standard deviations. So again, there's my normal distribution. So now 2 standard deviations is going to be a little further out, 2 standard deviations in each direction, right? So this is 2 standard deviations, and this is 95% of the observations are in between 2 standard deviations below and 2 standard deviations above the mean. Okay, now this is kind of like the empirical rule. The empirical rule says a vast majority of observations are within 2 standard deviations of the mean. Right, so now it's putting a number to it, 95%. So vast majority is kind of more vague, and this says that 95% of the data is between 2 standard deviations of the mean. The range rule of thumb, which says that vast majority lies within 2 standard deviations of the mean, does not require this approximate bell-shaped distribution. Although remember, it does say that it only works for a majority of distributions. So actually for highly skewed distributions, even the range rule of thumb won't work that well. All right. So then about 97 or 99.7 within 3 standard deviations of the mean. So if I were to draw this out, so 3 standard deviations is going to be pretty far away from the mean. Okay, so 3 standard deviations in each direction, and 99.7% of the observations are going to be within 3 standard deviations of the mean. All right, so let's do an example. So in a sample of 50 college students, a researcher found that their average age is 23 years old and standard deviation is 3.2 years. Okay, so what interval contains 68% of the college students' ages? So 68%, that's 1 standard deviation from the mean. So we would go ahead and take, so we would take the mean, and it says 23, and we would subtract off the standard deviation, so 3.2, and then we would take the mean, which is 23, we would add on a standard deviation, okay, to find the upper and lower limits of this interval. So this would be, let's see, 19.8, and this one would be 26.2. Okay, so what? So 19.8 to 26.2. So that means that 68% of the college students are between the ages of 19.8 and 26.2. Alright, so now let's find the interval that contains 95% of the college student ages. That's 2 standard deviations from the mean. So do 2 times 3.2 and 23 plus 2 times 3.2. So that's 23 minus 6.4 and 23 plus 6.4. Okay, so this is 16.9, not 9, 16.6. That's what I meant to say. So 16.6. And this would be, let's see, 29.4. Okay, so 95% of the students are between the ages of 16.6 and 29.4. 16.6. All right, so now find the interval that contains 97 or 99.7% of the college student ages. So that'd be 3 standard deviations from the mean. So 3 times 3.2 and 3 adding on plus 3 times 3.2. So that's 23 minus 9.6. 23 plus 9.6. Let's see, that would be 13.4 or 13.4, and let's see, this would be 32.6. Okay, so 99.7% of the observations, or percent of the college student ages, are between 13.4 and 32.6. All right, so 99.7% of the college students are between the ages of 13.4 and 32.6.